After some so-called property, which is about the shape, is regarded as geometry, and then we bring the shape by using coordinate system, and then that's why we have a more systematic analyze for many different shapes, and then that's rely on our basic understanding in coordinates plane, which is like this with x-axis, y-axis. This is called rectangular coordinate planes. It's because we always talk about horizontal and also vertical. So very basic things is you can locate the point on the plane to represent a position. Let's say if it is 1, 3, then you can find out that means go right by 1 and then go up by 3 from the origin. So that's why 1, 3 here. We find this point. And then we label this point A, 1, 3. Similar reason, we can also draw another point B. Let's say it's -3, 0. That means we go left by 3 and then we don't move up or down station from the origin. We move left by 3, we reach -3 horizontal position, and then we don't go up or down, remain the height is 0. So this point is our point B here. And then there are two things is very common in our coordinate geometry is we want to describe the relation between these 2 points. There are two things. The first thing is the distance, AB. The distance between 2 points, how do we find that out? The major advantage of using a regular coordinate plane is we can find out horizontal and vertical very easily. So that's why even though we don't know the strict length strict distance at this moment, but we know that means move right by 4 units. We have a horizontal distance 4, and also we have the vertical distance, which is 3. So therefore, in order to get the distance from A to B, is always a right angle triangle. So we say that delta x is equal to 4 and delta y here is equal to 3. That's why by Pythagoras theorem, the distance is delta x squared plus delta y squared. That means we use 1 minus -3. That means 1 plus 3 and then square plus the y difference is 3 minus 0 square. We get 5. Or more general, we say that the distance is equal to the first x coordinate minus the second one to get change of x, and also y1 minus y2 representing change of y. That's why we have the distance formula like this. This is the first relation between these 2 points. We know that how far away they are. And then a little bit more, we also want to know this line. Is the steepness of this line. Is this line very steep or is that relatively flat? That's why we have a measure of the steepness. It's called the slope of AB. Usually in our math textbook, we use M to represent slope because we are talking about the slope of this line. That's why we say MAB here. It is the notation of slope AB. And then it's defined by vertical distance compared with horizontal distance. To measure the steepness, for each change of x, what is the effect to y? That's the meaning of the slope. So that's why the slope is measured as delta y divided by delta x, or more general is y1 minus y2 over x1 minus x2. In this case, from B to A, we find that y increased, the height increased by 3. So delta y here is +3. And then x, we find that x from B to A is increased by 4. So this is positive 4. And then we say that the slope is 3 to 4. Or more general, if we apply the formula here, how can we get 3 is by using 3 minus 0. And how do we get the change of x? We use 1 minus negative 3. That's why we have 3 over 4 by using the formula. To remember this kind of formula, the best method is to understand why we design this kind of measurement. Remember the distance, we are going to solve it by Pythagoras theorem. That's why the format is look like Pythagoras theorem calculation. And then for the slope, we are measuring the stiffness. That means the ratio between the vertical distance per unit change of the horizontal number. So that's why we have this measurement. And then with a greater slope, that means every change of x will have a greater change in y. So for a greater slope, maybe it's like this, or maybe it's like this. For a lower slope, a smaller slope, that means it's less sensitive to change of x. Maybe it's like this, maybe it's like this. So with a more steep line, then of course we have a bigger measurement for the steepness. So that's why the slope should be bigger, slightly more normal, or maybe middle, and then a relatively small slope and the lowest slope here.